proving law of sines, we can work in this way. For example, we have here the angle beta. So let me take a pen. Let's say this is angle B and angle C. Angle C, now if we are looking at angle C here, the opposite side is H, and if we are applying here a trigonometric function sine C is going to be equal with the H divided by hypotenuse B. H divided by B. But if we are multiplying everything here by B, it implies the H is equal with the B times sine C. Now, if we are looking now with the angle beta B, angle B is sine B is equal with the opposite side, which is H divided by hypotenuse C. Is H divided by hypotenuse C. But now, if we are multiplying everything by C, from this implies H is equal with the C times sine B. And now we have a H here, and now if we are equating H is equal to the H, respectively, B sine C is equal with the C times sine B. C times sine B. And now, if we are multiplying everything by a sine C, sine B, what's going to happen here? So let me try it this way. I am multiplying the whole this equation by a sine B times sine C. Same thing, I'm dividing the other side. Sine B times sine C. What's going to happen? Sine C with the sine C simplifies. Sine B with the sine B simplifies. What remains here? Here remains a B divided by sine B. So it's a B divided by sine B. And in the other side it remains a C, because sine B and sine B is simplified. So it remains a C divided by sine C. So this is a relationship of what we can find between sines, between this angle B and angle C. But if we are taking, for example, if we are erasing this segment here, and we are constructing the new segment from the point B that is perpendicular to the segment AC, so we can construct a new segment. And now here we wanted to find, for example, the relationship of the sine A, this angle A here, and sine C. What's going to happen here? Here we are going to find the same relationship what we found here, but here we are going to find the relationship A divided by sine A is equal with the C divided by sine B. But let's prove it, this one here. So as we see here, the opposite of the angle A is this side here, and this side here. Now, if we want, for example, to find the sine A in this figure here, we have a H divided by hypotenuse C. So this is a H divided by hypotenuse C. And if we are multiplying everything here by C, so H is going to be equal with a C times sine A. So now if we are going with a C here, so the opposite of the angle C is this angle here H. But now the hypotenuse of this triangle is A. And if we want, for example, to find the sine C, so let me write it with a different color, maybe it's better. So sine C is going to be equal with the opposite side H divided by hypotenuse A. H divided by A. If we are multiplying everything by A here, what we're going to get? We are going to get here H is going to be equal with the A times sine C. And if we are going with the same idea, if we are going here with the same idea, With the same idea here, h we are equating with the h. So this h here, we are equating with this h. H is equal to the h. And instead now of the h, we take in the substitution, c times sine a. So let me put a little bit upper. So we can write here c sine a is equal to the a sine c. And now everything here we are going with the same idea. Here we are going to divide everything by sine a times sine c. Same thing I'm going to the other side. Sine a times sine c. Sine a with the sine a we can simplify. And the sine c with the sine c we can simplify. What we are going to get? We are going to get now here is a c divided by sine c, because sine a is already simplified. So is a c is divided by a sine c. And in the other side is a, because sine c and sine c simplified, so what remains? A divided by sine a. A divided by sine a. Okay, so if now we are going to get to the third figure here, for instance, if for example we are going to erase this segment here, and if I'm going to construct this segment from point C perpendicular to the segment AB, and if I'm using the same idea, we are going to get a similarly. So we don't have to prove it because it's just a consuming of the time, but we are going to get a similarly here the A divided by sine A is equal with the B divided by sine B. And now from these three equation we can conclude the sine laws, which is A divided by sine A. So let me write it with a different color, maybe it's better. So from these three equation, A is divided by sine A is equal to the B divided by sine B, and is equal to the C divided by sine C. So this is the law of sines, and this law it's applicable to all triangles.